we're going to be doing beta decay. So we're going to be doing beta plus and beta minus, beta plus and beta minus. So here we've got beta minus and beta plus. Right, so does anyone remember what the beta particle is? So the beta particle is the electron. Now, if you have an unstable nucleus, it will give off radiation. So if you remember, there's three types of radiation. There's alpha radiation, there's beta radiation, there's gamma radiation. So these are all radiation. So the beta minus is the electron that is given out. Why do we have radiation? What is radiation? If you have an unstable nucleus, it wants to be stable. So it will emit something. Now, in the nucleus, you've got protons and neutrons. What if we have too many neutrons? What if you have too many neutrons? So one of the neutrons will then become a proton. Now, what's the charge of the neutron? The charge of the neutron, so let's just say Q for charge. So the charge of the neutron is 0. What's the charge of the proton? +1. Now, if charge is conserved, something must be negative on this side. And what is negative? The electron. The electron is negative. So if you have too many neutrons, it becomes a proton, and electrons are also given out. And there is another particle, starts with N, it's the neutrinos, the antineutrino. Right. What's the quark structure of the neutron? If you remember in the previous video, the last video done previous to this, it is up, down, down. What is the quark structure for the proton? It is up, up, down. And these remain the same because these are fundamental. What is changed then? Can you see that this middle one, the down, has become an up? So if you just want to write down, if you ignore these, you can write down that the up has become an up quark plus an electron plus the antineutrino. So what has caused this to happen? Something called the weak force. So the weak interaction force. The weak interaction. The down quark has become an up quark, also emitting an electron and an antineutrino. What about beta plus? So the beta plus is the antimatter for the electron. So what's the charge of that? It would be E plus. So in the nucleus, if you have too many neutrons, one of the neutrons become a proton. What about beta plus? Beta plus if you have too many protons. So here you have too many protons. So the proton becomes a neutron, a positron is given out, and a neutrino is given. What's the charge? Let's do the charge. So the charge of the proton is +1. The charge of the neutron is 0. The charge of the electron is 1. The charge of the neutrino is 0. That makes it okay. It's conserved. So it's conserved. Just like this one. Here is also conserved. Because here you have -1 and you have +0. So that is conserved. Now, what's the quark structure for the proton? The proton quark structure is up, up, down. And what does it become? The neutron. So here you have up, down, down, plus a positron, plus a neutrino. So if we want to shorten it, you can say that the up quark has become a down quark. So this is the quark. If we want to simplify things, this is the beta minus decay in terms of the quark structure. In terms of the beta plus structure, this is the transformation